In this lesson, we're going to cover the product rule. Now, as its name implies, the product rule is going to give us a way of differentiating the product of two functions. So this is going to greatly expand the types of functions that we can differentiate. So the product rule states that if f and g are two differentiable functions, then f times g is differentiable, and the derivative of f times g is going to be f times the derivative of g plus g times the derivative of f. So you take the first function times the derivative of the second, then plus the second times the derivative of the first. It's not a very intuitive rule. Many people might incorrectly guess that the derivative of this would be the derivative of f times the derivative of g, but that is not the case, so do not make that mistake. It's very easy to make that mistake because, after all, the derivative of the sum of two functions, that is the derivative of f plus the derivative of g. That is absolutely true. That is true. And so you might incorrectly guess that the derivative of the product would be the product of the derivatives, but this is absolutely not correct, so do not make that mistake. It's very easy to make this mistake from the sum and difference rule, because this is true for the sum and difference rule, but it is not true for the product of two functions. So put a big no right here. So this is how you have to differentiate the product of two functions. So let's take a look at two examples, and then we'll look at the proof of this. So the first one, we want to evaluate the derivative of the product of these two polynomials. So dy dx is going to be, now we're going to treat the function right here as our f, and this one will be like our g in the statement of the product rule up here. So dy dx is going to be f times the derivative of g and then plus g times the derivative of f. Now we just have to evaluate the derivative of these two functions, and then that will be our answer. And then, if necessary, we can clean up our answer. Okay, so see what we have here. We have the derivative of 4x plus 5 being 4, so we evaluated that. And then the derivative of x squared plus 3x plus 2 being 2x plus 3. Remember, the derivative of 2 is 0, so that disappears. And then this is our answer. That's our answer. Now, normally if you're using a textbook and you're looking up an answer in the back of the book, you will want to simplify this a little bit if it's not too difficult to simplify. So in this case, this would simplify as, and then foiling this out, we're going to get 8x squared, 12x plus 10x, and plus 15. And then all of that would simplify out to 12x squared, 22 and 12, 34x, plus 15 and 8, 23. And there is our answer. Now you could have obtained the derivative of this without using the product rule by foiling out or expanding these two terms, just multiplying them together to get one third-degree polynomial, and then just use the power rule and the constant multiple rule, just differentiate that polynomial. But we showed you how to do that using the product rule instead, how to take the derivative of this using the product rule. Now, let's take a look at this one. Derivative, we want to evaluate the derivative of x cubed times sine x. Now in this case, the x cubed is going to be like our function f, and the sine x is going to be like our function g, being referred to up here. So dy dx, will be x cubed times the derivative of sine plus sine x times the derivative of x cubed. Now we just have to evaluate our derivatives. So it's going to be x cubed times cosine x put our parentheses around there, plus, and then sine x times derivative of x cubed is 3x squared. And that's really as far as we can simplify it. It's probably a little better to write this as, I usually prefer to bring the 3x in front of the sign, in front of any trig function, so there's no confusion that the 3x squared is not part of what the sign is acting on. So I like to put that in front as 3x squared times the sine of x. I prefer to write it like that. Alright, and there is our answer. So that is our derivative of x cubed times sine x. Now, let's take a look at the proof of the product rule. So to start out, we start out with the left-hand side, and then we want to use the limit definition of the derivative to obtain the right-hand side. So we start out with this. And we go back to the limit definition. Now what we're going to do is we're going to do one of those math tricks. We're going to add something in and subtract it back out. And this is what we're going to add in and subtract back out. Oh, that's a lot to write. And so now we divide all that by delta x. And so you see what we added in and subtracted back out were these two terms. We added in this term right here, f of x plus delta x times g of x, and it's being subtracted out right here. And so you see we still are left with then the f of x plus delta x times g of x plus delta x, and over here is our minus f of x times g of x. So we haven't changed anything. Now what we're going to do is group things together like this. We are going to group together these two terms. We're going to group those together, and we're going to factor out an f of x plus delta x. And then we're going to group these two together and factor out a g of x. And then we're going to split the fraction apart right at this plus. So what we end up with is this. So you see what we did is we just have these two terms right here. They are right here. That's the f times this g, and this f times that g give us those two terms. And these two terms over here are g times this f and g times that f. And then we just split the fraction apart. So we have there are two delta x's when we split it apart. Now let's notice this. As delta x goes to 0, f of x plus delta x, that is just going to be approaching f of x. Now what's this approaching? Well, that looks just like a derivative, and that is actually going to be approaching g prime of x. Now this term right here, the g of x, that does not depend on delta x at all. So that is always going to remain as g of x. And this piece right here, that looks like another derivative. That's the derivative of f. So that is approaching, as delta x goes to 0, that is approaching f prime of x. And let me say one more thing over here about this f of x plus delta x. You know, the delta x is going to 0, so basically we can just plug 0 in for that delta x and you get f of x. That also relies on the fact that f of x is continuous, and we know f is continuous because it's actually differentiable, because it was assumed to be differentiable. And we have a theorem that tells us if a function is differentiable, then it is continuous. So what we have here now, you see these two are being multiplied. These two are being multiplied, and that addition symbol comes down right here. And look at what we end up with. We end up with f of x times g prime of x plus g times f prime. And that is exactly what we wanted to end up with. We started with the derivative of f times g. We went back to our limit definition. We did some math tricks in here and a little bit of algebra. And we ended up with exactly what we wanted. F times the derivative of g plus g times the derivative of f. And that is how you differentiate the product of two functions. Alright, so that concludes our discussion of the product rule.